In this lesson, we're going to look at PLC tags and more specifically how we get information from our CPU hardware layer or PLC hardware layer through to our PLC tags. So this is taking information that's coming from the physical real world out in the field and putting it into our software for us to use. So it all starts with the PLC tags folder in the project tree, and I've gone ahead and created a new tag table and simply renamed mine as CPU IO. So I'm going to go ahead and delete the one it's just created. I was just showing you how it doesn't come up like an editor does, like when you're creating a function block or anything like that. It just creates a blank table. And you also can get into show all tags, which shows every tag across all the tables, which can be handy. But for this, for when we're setting up IO, the best thing to do is to have a dedicated IO table. So here I have CPU IO, and if we just go ahead and open that, we can see that we have all of the IO that's coming in and out of this PLC. So one of the first things to note is the naming convention, because every time that I've sort of spoken about this, it's not the normal sort of way of naming tags. However, there is a good reason for it, because when you look at the wider picture, when it comes to the asset-orientated approach, we only use these tags once. So the actual name of them, as in their actual function, so open feedback for AV01, close feedback for AV01, we don't really care about that on the tag, because it's going to go into a structured system where AV01 will be the name of the asset, and this will be mapped to the feedback signal, the open or closed feedback signal. So we don't really need to know what this actual tag is doing at this point. What's much more important is where is this information either coming from or going to. And that's what this naming convention does give you quite well. So S2 channel 0, this will be slot 2 channel 0. And if you go ahead and look at your device configuration, which I have open here, that tells us slot 2 channel 0. And if we go and have a look at the properties for this and click IO tags, we can see slot 2 channel 0 is mapped to the address I0.0. And if we have a look at the addressing for slot 2, we can see in this table here on the device overview, slot 2 digital inputs addresses start at 0 and they end at 1 inclusive. So that means that 0.0 will be our first channel on the digital input card, which you can see in the tag name. So the reason I like doing this is because when you start trying to marry things up with drawings and things like that, a simple note on the drawing or in the documentation that says slot 2 channel 0, which is quite a normal thing to see, makes it very, very easy to follow everything through. So slot 2 channel 0, you get the address as well, which you'll be able to see on the tag, and then the comment tells you what its function is in its raw format. And when we go through the input mapping layers in the next lesson or in a future lesson, we'll then see how we move past the S2 channel 0 and into a actual variable called open feedback, and how that sits in the space of the asset data. So once you've done that for all of your inputs, we have exactly the same for the outputs. If I go ahead and look at the IO tags for the outputs, I haven't named any of these ones yet, but here we would put in S3 channel 0, and all you're doing is changing this to CPIO, and you would name the comment as its function, like we did with the inputs. So this might be AV01 open command, for example, and you fill the rest of the table in like that, and anything that you put in this drop down here will immediately appear in the CPIO this is more of a filter for the tags. We'll be able to see in here that S3 has appeared on the end here. So I'm not quite sure why I didn't do S3. I think I did leave it so I could show you how to actually fill a tag in on this lesson, but I've done all the other ones. So yeah, when we go through the input and output mapping layers, we won't go through the output mapping layer until quite a way into the course because it's done right at the end. It's the last thing that we do. But these tags are also part of the simulation system as well, which we'll go through during the input mapping section as well. And that's pretty much it for this lesson. However, just before we leave, it's worth showing you this, that if you name your tags this way, you can make use then of this drop down, which makes things a lot easier. So if you grab this little square in the bottom right hand corner, just like on Excel, you can then pull this down and you can pull this down, and when you let go, it'll pop up saying, sorry, I thought it was going to pop up saying, do you want to overwrite these? But that's only if you've got stuff underneath. But yeah, it'll fill in the sequence. It'll continue the sequence on. It's just a nice quick way of filling it in because it also puts the addressing in as well. Alternatively, it's not the best way to fill it in the tag table. It's much better to actually fill it in on the card, double clicking the card and going to this IO tag tab, because the addresses are fixed then. So you know you're not going to miss any. You know you can't put something in wrong. You can't accidentally put it in the wrong place by typing in the wrong address. It's far easier to actually fill it in here, and the dragging works in here as well. The only thing is it will put it in the default tag table, which you just need to make sure you change. And you can do that by dragging the right one down and saying overwrite. Just little things like that that make things a lot easier. So in the next lesson, we're going to be looking at moving this information into our assets.